Hi everyone, just wanted to take a moment to talk a little bit about fractions and kind of some of the operations involved with them. So our goal for today is going to be for us to identify least common multiples, two numbers to rewrite fractions with common denominators, which will be needed to then add and subtract fractions, and then multiplying and dividing doesn't necessarily use that, but they're all kind of interrelated. So first of all, what is a fraction? Well, it's going to represent a part of a whole. And it's kind of essentially telling you it represents a number of parts of a certain size. So if you kind of think of it in real terms, right, a fraction of the cake is part of the cake. In this case, you cut it into four equal parts. You have a fourths, right? You cut into thirds, fifths, sevenths, eighths, ninths, whatever. In terms of the different names for things, the numerator will be the number on the top. That's essentially the number of parts you have, right? I have 3/4. I have three 1/4 pieces, right? Right, this is three 1/4 pieces, so I have 3/4. And then the denominator, that's the total number of parts, right? In this example here, we cut this into 4 parts, so that's why 4 is the denominator. In this case, we cut this bar into 5 parts, so that's why the denominator is 5. Now the fraction bar will be the number the line in between. You don't necessarily need to remember that, it's just that's the name of it. Now, when you're comparing fractions, because sometimes it can be a little bit tricky on, which one's bigger, which one's smaller, things like that, the easiest thing for you to do is to find the same denominator. When you have the same denominator, you know that the bigger numerator will be the bigger fraction, right? If I have eighths as my denominator, right, I have an 8 in the denominator. If I have 6/8, I know that's more than if I had 2/8, right? 2 plus 6. So how do we actually do that? Well, we do something called finding the least common denominator, which comes from finding the least common multiple. So if we were to compare 3/8 and 5/12, you have to find the least common denominator of the fractions. In this case, the least common denominator will end up being 24. So when you convert everything to a 24, right, you multiply this one by 3, and remember, whatever you multiply the denominator by, you have to multiply the numerator by. So you multiply the denominator by 3, you have to multiply the numerator by 3. You get 9/24. In this case, right, you have to multiply by 2, so you multiply the numerator by 2 as well, right? Then you get 9/24, 10/24. 10/24 is obviously bigger. Now, more explicitly, how do you actually do this with finding the least common denominators as opposed to just saying, oh, it's 24? Well, you essentially will just take your denominator and keep multiplying it, right? 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5. And you kind of just list those out until you find the first number they have in common, right? So in this case, 4 and 5, they have 20 in common. When in doubt, a common denominator will always be the two denominators multiplied together, right? If I had 7, 12, right? I could do 7 times 12, that'll work. In that case, that is also the least common denominator. However, we just saw an example on the last one where 8 times 12 is obviously not 24, but 24 is a much lower number, right? So it's easiest if you do the least common one so you can make it work a little bit better. Now, I have to compare these. So if I have 1/4, I have 4 times 4, 8, 12, right? Let's look at different multiples. 6, 12, oh, and we found one in common. So this I just have to multiply times 3, times 3. This one I have to multiply times 2, times 2. So that's 3/12 compared to 4/12. Now obviously 4/12 is bigger than 3/12, so this one is bigger. Now, that's exactly what I'm saying, though, from before. You can find a common denominator if I just multiplied this by 6 and this by 4. However, that would give me things in 24s as opposed to 12s, and 12s are smaller and better to work. Or let me rephrase that. 12 is a better number to work with than 24. Now, when you're adding and subtracting fractions, the only thing you have to do is combine the numerator as long as they have the same denominator. Right? If I'm trying to add like third and fifth, it doesn't kind of make sense right off the bat. I have a third of a cake and a fifth of cake. Well, what is that when I combine them? A third, 3 parts might not be the best way for me to describe it. 5 parts might not be the best way to describe it. So we have to find a common denominator for us to describe it. So what you're going to do is you're going to find the least common multiple and rewrite the denominator into being the same. Then you will add the numerators, as you can see here. 2 plus 4 is not what I'm doing. However, when I convert this and multiply everything by 2 here, 4 plus 4, right? And then you just add the numerators. Do not add the denominators. Okay, so 4 6 plus 4 6 is not equal to 8 twelfths. No, do not add the denominators, just the numerators, right? This is essentially the total part. You're not changing the total. You're just changing the number of parts you have. Now, that being said, you are ending up with 8 sixths. Now, you should simplify that as much as possible, right? They both have a 2 in them, so you can take that out. So you get 4 thirds. Please remember to simplify if possible. Another example in this in terms of subtraction, again, they're the same thing. They just need the same denominator. You need to get a common one. So in this case, it's 15. Multiply, subtract just the numerators. Do not touch the denominators. You do not zero in the denominator. It's saying I have 0 parts, right? That doesn't make any sense. So in this case, what do I need to do? Well, I need to multiply this by 5 times 2 to find my least common denominator. What's that? That's 15 over 10 plus 8 over 10. It's going to be 23 over 10. And I can't do anything with that. I'm just going to leave it as an improper fraction. I can't simplify it. Unless I want to write it as a mixed number, but why? Don't spend the time. We already know 4 and 5 only have a common denominator of 20. So this is 15 twentieths minus 4 twentieths, which gives you 11 twentieths. And we're going to leave that alone. Now, the next thing that we need to do with multiplying fractions is, now we actually have to worry about the denominators, right? When you multiply fractions, what you're going to do is you're going to multiply the numerator times the denominator, all right? So you have 1/2 times 20 over 18. Don't forget to multiply both the numerator. 1 times 20 is 20, 2 times 18 is 36. However, then you should simplify as much as possible, okay? The way you can kind of think about this is you're saying I have a certain part and I'm multiplying it by another part. You can almost think of it as like you're multiplying it by almost like a percentage of what you have. So that kind of can help you kind of rationalize what you're doing here. So for something like this, right, what am I going to do? 3 times 10 is 30. 5 times 8 is 40. Now I'm not going to leave it like this, right? They both have, that's 3 times 10. That's 4 times 10. So that's 3 over 4. Okay. Now, last thing is dividing fractions. When you're dividing fractions, it's the same as multiplying by the reciprocal. Now, multiplying by the reciprocal just means you take the fraction on the right, the one that you're dividing by, you flip it. Okay, and the reason we do that just comes down to, in order to essentially get these things to cancel out, right, you would need to multiply the numerator by the denominator and the denominator by the numerator, so you cancel out and get a 1. That's where it comes from. But ultimately, for the purposes of dividing fractions, you essentially are going to keep the first one, change this to a multiplication, and then flip the second fraction, or multiply by the reciprocal. So as an example here, 1/3 divided by 2/5, you have to remember to keep, change. I'm sorry, yep, keep, change. Oh, I don't know why they wrote it that way. Ignore that. So 1 times 5 is 5. 3 times 2 is 6. So my answer is just going to be 5 over 6. That's it. So all you do is you flip, keep, change. All right, so for example, I'm going to rewrite it. I'm going to keep the first one, multiply by the reciprocal, which is the same as keeping the first one, changing the second one to, changing the symbol to multiplication, and then flip to get this, right? So this is the reciprocal of this. You write it out. You get 24 over 28. Now I need to find, that can be simplified. They both can be divided by 4. That's going to be 6/7. And there you have it. So that's all there is to dividing. So at the end of the day, in terms of what we're doing, we're adding and subtracting. You need to get the same denominator, then just combine the numerators. Multiplication, you're just going to multiply the numerator times the numerator, denominator times denominator. And with division, you multiply by the reciprocal, right? So you leave the first fraction alone, you have multiplication, and then you take the other fraction and flip it. And that, again, just comes from division, where you're kind of writing it as a fraction over a fraction, and to undo the denominator, you multiply by the number in it. So anyway, let me know if you have any questions, and have a great day.